Okay, sir.
So normal reaction, tension, friction, and last one is spring force. So we should discuss this spring force. Yes. See, fifth one, uh, spring force.
So tension is completed, sir.
Yes. So you might have seen springs. You might have used them. If you take a straight wire and like this in helical shape, you get a spring. Okay. Now every spring will have its natural length. Natural length. Natural length means when it is neither elongated nor compressed, the length of the spring you call it as natural length. Let us say this is some uh, L. L is the natural length of this spring. Okay. If I fix one end of this spring and apply a force on the other end in this direction so that the spring is stretched, it will be something like this. It is something like this. I am applying a force F here, pulling it. Okay, then the spring is elongated or the spring is stretched. By what amount is it stretched? This was its natural length. Now it is elongated by this. Let us say this elongation is some x. The spring is stretched or elongated by some length x. Let us say original length is some 10 centimeter of the spring. You are pulling it so that its length becomes 12 centimeter. Then its elongation is 2 centimeter. Okay. Uh, from this situation, if you remove this applied force, what happens? The spring immediately goes back to its initial configuration or its natural length. Okay, that means what is happening here? Something is pulling back this spring. Something is pulling back this spring to its natural length. Who is pulling it back? Obviously, it must be a force. It must be a force. We uh, So when you change the configuration of a spring or when you elongate or compress a spring from its natural length, a restoring force will be developed in the spring. Restoring force, we call it as restoring force. In which direction? In this direction. Restoring force. And this restoring force, we call it as spring force. Restoring force means a force which tries to restore the initial condition of a body. We call it as restoring force. So, the restoring force which tries to pull back a spring to its normal length, we call it as spring force. Okay. In another situation, instead of elongating the spring, I am compressing it. I am compressing it by applying a force in this direction, external force in this direction. How much is the spring compressed? This is the natural length, and this is the compression. Let us say this is also some x. Spring is compressed. Now, if you remove this applied force, what happens? You see that the spring stretches. It comes back to its natural length again. What is this? Who is responsible for this? Again, the restoring force which is developed in the spring.
But it's pushing, sir.
Which direction should this restoring force should be developed? In this direction, opposite. If you observe this restoring force or spring force, I will call it spring force. When the applied force was towards right, restoring force was towards left. When the applied force is towards left, restoring force is towards right. Spring force is towards right. That means the spring force is always opposite to the applied force. So first point is it is the restoring force developed in a spring when it is either elongated or compressed. Next point is spring force is always opposite to the direction of upward force. Applied force. Okay. Another thing is this spring force Fs. It is directly proportional to the elongation or compression. It is directly proportional to elongation or compression. Larger the elongation, pull the spring to a larger elongation, leave it, it comes back very quickly. Compress it very highly, leave it, it comes back very quickly. So that indicates the force which is developed inside the spring is directly proportional to the displacement or elongation or compression, directly proportional. And also it is opposite. So to indicate that opposite direction, we put a minus here. So spring force is directly proportional to displacement or elongation or compression and opposite in direction. The proportionality constant that you get is K. K. K is,
Sir, what is
we
Fs,
call
sir?
it as spring force, spring force. We call this K as spring constant. This K is called spring constant. On what factors does this spring constant depend? It depends on the nature of the material of the spring. It depends on different factors like material with which the spring is made. Next, it also depends on length of the spring. Then it also depends on area of cross section of the spring.
Sir, Fs is proportional to minus x. Fs is directly proportional to minus x means the force applied here.
What is Fs?
Spring.
Spring force. So it is self-explanatory, no? F and the suffix s means we are discussing about spring force here. So obviously this indicates spring force.
No, sir. Minus x represents the force applied, sir.
Minus x, what is x here? Where did we use x here? This is x, this is x. What is x? Is it force or is it the displacement of the spring?
Displacement.
So all the terms, any term that we use in a formula will be coming from the situation that we are taking. So you must have clarity on the situation first. Then you can easily understand the terms. And many students, they find they have this difficulty. They could not relate the terms with the physical concept or with the physical situation. That is a very important problem which you should overcome. Okay, see, physics is a quantitative subject. We measure everything, we compare everything, we represent something happening in terms of some physical quantity, some mathematical relation like that. So you should be able to connect physics and maths. That is very important. So K is spring constant and it depends on these three factors. Material with which the spring is made, length of the spring, natural length, and area of cross section of the spring. And it also depends on the number of turns in the spring. Number of turns in the spring. Okay. How can we define this spring constant? See, K can be written as its magnitude as spring force by X. If X is equal to 1 meter, what is X? Displacement means not due to motion of the spring, due to elongation or compression. X is elongation or compression. If I make the value of X equal to 1 meter, as it is elongation or compression, should measure it in meter. So if I make the value of X as 1 meter, then what is K? It is equal to spring force. That means, can we understand or can we define the spring constant as the force required to elongate or compress a spring by unit length? Suppose you have a spring like this, okay, and I will apply a force on the spring such that its elongation becomes 1 meter. It is elongated by 1 meter. X value is 1 meter. Then to do this, in order to elongate the spring by 1 meter, how much force you need to apply? That is spring constant. The force required to elongate the spring by unit length is spring constant. Or in simple words, spring constant represents the rigidity of the spring. K represents the rigidity of the spring. What do you mean by rigidity? You have springs in your pens, right? You have those tick pens in which there will be a spring. If you take out that spring from your pen and try to elongate it or compress it, you can do that very easily by applying very little force. And you have springs in gyms which are used to do exercise. And if you want to elongate the spring, you need to apply a lot of force. It is very difficult. Okay. So the spring that you are using in gym, its K value is very high. It is very rigid, not easily, not able to, you are not able to elongate or compress, not compress, mostly elongate it easily. K value is very high. And the spring that you find in your pen, its K value is very low. This is what K value indicates. Greater the value of K, spring constant, larger the force you need to apply to elongate it or compress it. Smaller the value of K, lesser the force you need to apply to elongate it or compress it. That is what K represents, spring constant. Okay, so it is force by displacement. So what should be its unit? SI unit of spring constant, Newton per meter. Newton per meter. For example, if for some spring, its K value is 10 Newton per meter. What should you understand from this? You should understand that for that spring, in order to elongate it by 1 meter, you should apply a force of 10 Newton. Or for some other spring, if K is say 100 Newton per meter, then to elongate this spring by same 1 meter, you should apply 100 Newton force. That means this spring is more rigid. That is spring force. Kx minus Kx. Spring force is minus Kx. Okay, right. So these are the common forces that we encounter in mechanics: weight, normal reaction, tension, friction, and spring force.
Sir,
Hmm.
sir, I did not understand how Fs is proportional to minus x, sir.
Longer the or greater the stretch that you are bringing in the spring, quicker it will go back. That means
Oh,
if you are pulling it more, the spring is pulling itself back more.
okay, sir. Sir, and rigidity means strength, sir.
Rigidity means opposition to change its size or shape. Resistance to change the size or shape of something is rigidity. Right, these forces you should be very clear with these forces, because in the coming chapter, coming topics, we will be using any one of these forces. Weight, it is due to mass and gravitational force acting on a mass. W is equal to mg. Normal reaction, whenever two bodies are in contact with each other, there will be normal reaction. Tension, when you connect bodies with strings, then if the string is loaded by a mass by a body, then tension will be developed in the string. Friction, depending on the surface, the opposition offered or the uh, opposition to the relative motion between two bodies over each other, you call it as friction. And this spring force, whenever a spring is elongated or compressed, a restoring force, spring force, is developed in it, which is given by F is equal to minus Kx. Okay. Next thing. We should study motion of bodies, particularly connected bodies. Connected bodies. What is this? In previous classes, I think we studied, suppose you are given a body of mass some 2 kg and you are applying some force 10 Newton on it. What is the acceleration of this body? Or if acceleration is this much, how much force is applied? Or force is given, acceleration is given, what is mass of the body? We did some questions like this, which are based on F is equal to m, Newton second law. But those were for single bodies, isolated bodies. If two or more bodies are connected together and they are moving as a system, then and you are asked to find out the acceleration of the system or how much force is needed to move that system, questions like this, then what should you do? That's what we study in connected bodies. Okay. In this first kind of concept is bodies in contact. Bodies in contact. Okay. What is this? We'll understand all these things with examples directly. Suppose right, this is a horizontal surface, smooth horizontal surface. Smooth horizontal surface means you can ignore friction. First of all, we will study motion of bodies without considering friction force. Then we will repeat all the concepts again by considering friction force. This is this total chapter. So wherever you read the word smooth surface, you should understand that in this situation, friction is being ignored. You need not worry about friction. But in the question, if it is said that rough surface, then you should include friction. So you should consider friction. We'll come to that situation later. First of all, this is a horizontal smooth surface. And on this surface, we have a body of mass 4 kg. Another body of mass 2 kg. These two bodies are in contact with each other. They are in contact with each other. Okay. And on 4 kg body, I am applying a force of 12 Newton. I am applying a force of 12 Newton. What happens? These two bodies move. They start to move. If they are moving, how do they move? With constant velocity or with acceleration? With acceleration, because wherever there is force, there will be acceleration is equal to m. Now the question is, what is the acceleration? Find acceleration of each block. This is the question. Okay. Acceleration of each block. First thing that you should understand is, if you are doing this, applying force on 4 kg and 2 kg, which are in contact with each other, how will they move? Will they move together or will they move separately? They will move together. Okay. If they are moving together, how should be their accelerations? Same or different?
Sir, different, sir.
If they are having different accelerations, they cannot be in contact.
Sir, same acceleration, sir.
They should be having same acceleration. Then only they will be in contact with each other. Fundamental point. Common sense. This is not science, this is only common sense. If the blocks are to move by maintaining contact between them, they should move with same acceleration. You and your friend are running, holding hands. If you should not leave your let your hands go off, you should run with same speed. If your friend runs at 15 meter per second and you are running at 10 meter per second, how can you hold your hands? Both of you should be running either at 15 meter per second or 10 meter per second. So here, if the contact is to be maintained, the two blocks should be moving with the same acceleration. As the blocks are in contact, both will have same acceleration. That is the basic one. Okay, now how much is that acceleration? Okay. Again, or before going that, if you just think about this situation, how much force are you applying? 12 Newton. Where on 4 kg? 12 Newton force is applied on 4 kg block. Okay. That means this 12 Newton is pushing 4 kg block. So because of that force, it gets accelerated. Fine. Okay. But who is pushing 2 kg block? Is it this 12 Newton force?
The 4 kg block, sir.
How can 4 kg block push 2 kg block?
Sir,
We
the
are
12,
applying
By applying
12 Newton force.
12 Newton force. This 12 Newton force, as it is passed to 2 kg.
No,
12 Newton force is responsible for acceleration of 4 kg block. Okay, because it is applied on it. Understandable. But who is accelerating 2 kg block? You are not pushing 2 kg block directly. You are pushing.
the 4 kg block is pushing the 2 kg block, sir.
How can a 4K? How can one block push another block?
Because we are giving acceleration and force to the first
Normal
block
reaction.
pushing
By
the second.
applying normal reaction. By applying normal reaction. What is happening here? If you look closely. This is 4 kg. This is 2 kg. 12 Newton applied directly on 4 kg. So it is pushing it. 4 kg pushes 2 kg. How? By contact. 4 kg pushes 2 kg by contact. So what is this force? You can call this force as normal reaction. The force which comes into action due to contact between two bodies is normal reaction. So normal reaction need not always be upward. It can be horizontal, it can be it can act in any direction, but the direction will always be perpendicular to the surface with which the body is in contact. Okay, so 4 kg applies force on 2 kg, right? I will call this as force by 4 kg on 2 kg. Okay, then if you remember Newton's third law, for every action there will be an equal and opposite reaction. If 4 kg is trying to push 2 kg, 2 kg will also push 4 kg in the opposite direction.
And the 4 kg will also push me, R, sir.
So this is force by 2 kg on 4 kg. This is action. This is reaction. Okay. Now, the force which is responsible for motion of 2 kg block is this. It is this force. Okay. And again, we discussed this earlier in detail also. These two forces, they cannot cancel each other because they are acting on two different bodies. They cannot cancel. Right. Now, what is the acceleration of the two blocks? Suppose if the question was like this, there was only 4 kg block and you are applying 12 Newton force. If I ask you acceleration of this, what is the acceleration? F equal to ma, a is equal to f by m, 12 by 4, 3 meter per second square is the acceleration. Okay. Here also use the same formula because for acceleration we have only one formula, F equal to ma. F equal to ma. Okay. And to write this formula clearly in more detail, you should write it like F net equal to ma. If there are more than one bodies, then in place of mass, you should write total mass into acceleration. F net equal to total mass into acceleration. From this, acceleration is equal to F net by total mass. What is the net force? There is only one force applied, which is 12 Newton, divided by what is the total mass? 4 kg plus 2 kg. 12 by 6, 2 meter per second square is the acceleration of the system. Two blocks combined acceleration. And if I ask you what is the acceleration of 4 kg, it is same 2 meter per second square. Acceleration of 2 kg, 2 meter per second square, same thing because they are moving in contact with each other. Both the blocks will be having same acceleration, 2 meter per second square. Okay. Then suppose I want to find out what is the force acting on 2 kg block. What is the force acting on 2 kg block? To understand this, here, here, oh, here we get a concept called free body diagram. Very important, very frequently used term in this chapter. Free body diagram. In short, we call it as FBD. FBD. What is this FBD? Simply, it is a figure which shows a figure or a diagram which shows all the forces acting on a given body. That's all. Free body diagram is a diagram which shows all the forces acting on a given body. Now, given body of the system. Let us say given body of the system. Now here, this is our system. 4 kg and 2 kg bodies together is our system. Out of this, I want to find out what is the force acting on 2 kg body. Force acting on 2 kg body. For that, to find force on 2 kg, draw FBD of 2 kg. Draw FBD of 2 kg. What is FBD of 2 kg? Diagram which shows all the forces acting on 2 kg. So for that, you take 2 kg separately from the system. You remove 2 kg block and take it separately. This is the 2 kg block. Only that block. If there are any other 1, 2, 3 other blocks, forget them. You take only this 2 kg block. Okay. And on this 2 kg block, what are the forces acting? As you can see here, force due to 4 kg, normal reaction by 4 kg and 2 kg is acting. It is this. Okay. This. Let us say this is F dash. F dash. Force on 2 kg due to 4 kg. Okay. And any other force?
Sir, the friction or force due to 2 on 4.
That's what I told in the beginning. We will ignore friction. We'll forget friction for some time. For another 1 or 2 classes, we'll forget friction.
Normal reaction.
Normal reaction due to?
Due to 4 kg blocks, sir.
That's what is I'm representing as F dash. Other than that force, are there any other forces on 2 kg?
The gravitational force.
Don't call it as gravitational force, you call it as weight. We have given a name to that.
Weight.
How much?
Sir, 20.
10 meter per second.
20 newtons, sir.
In which direction?
Sir, vertically downward.
This is the weight of 2 kg block. How much will be its weight? 2g. W is equal to mg. Mass is 2 into g. 2g. Don't think that this g is gram. It is not gram. 2 into g, acceleration due to gravity. W is equal to mg. Okay. Weight is acting vertically downward. Then any other force?
Sir, the normal reaction due to gravitational force.
Normal reaction not due to gravitational force. Normal reaction due to the surface.
Reaction.
Force cannot give normal reaction. Surface can give normal reaction.
Okay, sir.
So normal reaction, if this 2 kg block is in contact with the surface, if it is resting on the surface will give normal reaction on it in this direction. Yeah. And how much will this normal reaction be? Same as equal to weight, 2g. That's why these two forces are balanced. Which two forces? Weight and normal reaction. Weight downward, normal reaction vertically upward. These are balanced because they are exactly equal and opposite in direction. They are balanced, and if they are balanced, they will get cancelled. That's why this 2 kg block is neither moving in upward direction nor in downward direction, because net force along vertical direction is 0. It cannot move either upward or downward, and it is moving only along in this direction. Why? Because of this force. Okay. So strictly speaking, you should show these normal reaction and weight also in the free body diagram. But along as you do a lot of questions, you will understand that they do not matter because they are getting cancelled. So you can eliminate them. Strictly speaking, they must be shown. But with passage of doing number of questions, you will understand that even though you show them, they are of no use. So we don't show them. You will understand that while you go on solving number of problems. Right. So what is the net force here? The net force is F dash only. F dash only. Okay. And how much is F dash? F dash is equal to M into A. What is M? 2 kg. What is acceleration? We have got acceleration here. 2. So F dash is equal to 4 Newton. What is this F dash? Force acting on 2 kg block. If you are applying 12 Newton force on 4 kg block, only 4 Newton force is acting on 2 kg block. Right? Because of that 4 Newton force, 2 kg block is getting accelerated with 2 meter per second square. Is this clear? There are no complications. We are just going into details. That's all. 12 Newton is pushing 4 kg, 4 kg is pushing 2 kg. With how much force acting on 2 kg? You take the free body diagram of 2 kg. F dash is acting. Mass is 2 kg. We already have the acceleration, 2 meter per second square. So F dash is 2 into 2, 4. Similarly, if I draw free body diagram of 4 kg, FBD of 4 kg. Horizontal surface, 4 kg block. This is up. You should show all the forces acting on 4 kg block. What is this applied force? 12 Newton is acting on it. Okay. Weight 4g is acting vertically downward. Normal reaction due to the surface is
Sir,
acting
8 Newton.
vertically upward. And there is also this normal reaction on 4 kg due to 2 kg. If 4 kg is pushing 2 kg, 2 kg will also push 4 kg. How much is this? This is F dash, what we found here. It will be equal and opposite, Newton's third law. And how much is F dash? We have got it 4 Newton. We have got it 4 Newton. These two will get cancelled. And the net force along horizontal direction is 12 minus 4, 8 Newton. 12 minus 4 is 8 Newton. 8 Newton. Okay. And due to this 8 Newton, you can cross check whether it is right or wrong, because acceleration of 4 kg block is 2 meter per second square. Its mass is 4. So how much should be force acting on it? Ma. M is 4, right? And the acceleration is 2. 4 into 2 is 8. This is 8. Correct. So even though you see that you feel that 12 Newton is acting on 4 kg, in reality only 8 Newton is acting on 4 kg. The other 4 Newton is balanced. It is cancelled by normal reaction given by 2 kg block. Because of this 8 Newton, it's getting accelerated by 2. 4 into 2, 8. That's correct. This is what is happening there. When these two blocks are moving, this is happening. Okay.
Sir,
Hmm.
so why did you wrote the weight of 2 kg and 4 kg blocks as 2g and 4g?
These are weights. Weight, go back to normal reaction. If a body is present on a surface, its weight will be acting on the surface. If you are standing on floor, your weight is acting on the floor. If your mass is m, what is your weight? M into g, right?
Okay, sir. Sir,
Oh.
Sir, here F net is 12 minus 4, no, sir.
Hmm.
Which 4 did you subtract, sir?
There is only one force, which is this force. How can I subtract mass from force? It is meaningless. We should not even get that idea that this 4 is this 4 kg. It is totally absurd, right? It is
Yes.
completely illogical to subtract mass from force. Right, this is one simple situation. And this is homework for you. This question is homework for you. This is 6 kg. This is 3 kg. This is 3 kg. And this is 1 kg. Force applied is 20 Newton. Find acceleration of each block. Number 1. Number 2. Find force acting on each block. 2 questions. Homework for tomorrow. Okay, so that's all. We'll continue tomorrow.
Thank you, sir.